Welcome, grade 9 students from St. Paul American School, Clark. Let's jump right into this explainer on geometry, Unit 5, Lesson 6. Today, we're zeroing in on one specific, super important concept, solving right triangles. By the time we wrap up, you'll have a rock-solid, reliable roadmap for unlocking the secrets of literally any right triangle that comes your way. Let's get into it. Here's our game plan for today. We'll start with our objective, which is solving right triangles. Then we'll look at the essential tools we need. After that, we'll walk through a worked example together, pause for a quick misconception check, do a short formative check to test our skills, and finally wrap it all up with a lesson recap. All right, first up on our agenda, our objective, solving right triangles. So what exactly does it mean to solve a right triangle? Well, it basically turns us into mathematical detectives. You know that every triangle has 3 sides and 3 angles, right? But usually you're only given a couple of those pieces. Solving the triangles simply means doing the detective work to track down every single missing side length and every missing angle measure until the whole puzzle is complete. Moving on to Section 2, let's talk about the essential tools you'll need in your mathematical toolkit to pull this off.
Okay, this is an incredible shortcut you'll definitely want to remember. It's the corollary to the triangle sum theorem, and it proves that the 2 acute angles of a right triangle will always add up to exactly 90 degrees. Think about it. All 3 angles in any triangle must add up to 180 degrees, right? Well, the right angle already eats up 90 of those, leaving exactly 90 degrees to be shared between the other 2 angles. They are literally always complementary. Such a time saver.
So breaking it down, our toolkit really just needs 2 main strategies. When you're hunting for a missing side length, you're going to use the Pythagorean theorem. Good old a squared plus b squared equals c squared. And when you're looking for missing angles, you use that complementary rule we just talked about. You just subtract whatever acute angle you know from 90 degrees. So missing sides mean algebra, and missing angles mean simple subtraction. Section 3. Let's see how this all comes together in a worked example. Let's actually put this into practice. Imagine you've got a right triangle. You know one angle is 37 degrees, one of the legs is 3, and the hypotenuse is 5. Step 1, let's find that missing angle. We just take 90, subtract 37, and boom, we get 53 degrees. Done. Step 2 is finding the missing side, so we bring in the Pythagorean theorem. We set it up as 3 squared plus b squared equals 5 squared. Well, 3 squared is 9, and 5 squared is 25. If we subtract 9 from 25, we're left with 16. Finally, step 3, the square root of 16 is 4. And just like that, side b equals 4. And our triangle is completely solved. Pretty satisfying, right? Okay, moving right along to Section 4, a quick misconception check. Now, even with the best tools, there's a massive trap out there that you absolutely need to avoid. Careful identification of the hypotenuse is the absolute key to setting up your equations accurately. Seriously, if you accidentally plug a leg value into the hypotenuse spot in your equation, your final answer is going to be completely wrong, no matter how flawed your algebra skills are. Just always remember, the hypotenuse, which we label as C, has 2 non-negotiable features. It's always the longest side, and it's always located directly across from the 90-degree right angle. Here's a pro tip for you. Before you write down a single number or equation, find that right angle, draw a visual line straight across the triangle, and label that opposite side C. Do that every time, and you'll be golden. All right, Section 5. Let's do a quick formative check to see how we're tracking. Let's test out that complementary angle tool. If you're looking at a right triangle and one acute angle is exactly 67 degrees, what's the measure of the other one? Take just a quick second to calculate that in your head. Did you get 23? If so, spot on. Since the 2 acute angles have to combine to equal exactly 90 degrees, we literally just subtract 67 from 90. See? No complex equations needed, just a solid grasp of how triangle properties work. And finally, Section 6. Let's jump into our lesson recap. To wrap up this explainer, I want you to lock in these 4 pillars. First, solving a triangle means leaving absolutely no side or angle unknown. Second, rely on the Pythagorean theorem to track down those missing sides. Third, remember that acute angles in a right triangle are complementary, so a quick subtraction from 90 gets you that missing angle. And finally, always double-check your hypotenuse placement before you do any math. You've done an awesome job mastering how to find those missing pieces today, but I want to leave you with a bit of a provocative thought to chew on. How might you use these exact same algebraic tools but in reverse? Like, Could you use them to prove whether a mystery set of 3 side lengths actually forms a right triangle at all? Pondering that is going to set you up perfectly for your next big geometry challenge. Thanks so much for learning with me today.